Now, in this video, we're going to analyze one more problem on projections of lines. The problem number 45. It reads as a line capital AB measuring 70 mm has its end capital A 15 mm in front of VP and 20 mm above HP, and the other end B 60 mm in front of VP and 50 mm above HP. Draw the projections of the line and find the inclination of the line with both the reference planes of projections. So now we are going to take up this problem. So as it says, a line capital AB measuring 70 mm. As it says that line capital AB of 70 mm length, obviously that should be true length. Has its end A 15 mm in front of VP and 20 mm above HP. So when you look from the front view, you can see the distance above HP, so which is that distance. So now we talk about the pen. When you take this front view, here this is the front view what we are talking about. When you look from the front view, I can see the distance above HP. That image is seen in the vertical plane. So from this XY line, so this is X and this is Y now. So when you look from the front view, I can see the distance above HP. That distance is seen in the vertical plane. Similarly, as you look from the top view, I can see the distance which is in front of VP. That image will go to fall on HP, which is small a. Then he says line capital AB measuring 70 mm long. So since he says it is 70 mm, so what we can do, we are going to draw a line of 70 mm length, which is angle is not given. So now what we want, the other end B is given 60 mm in front of VP and 50 mm above HP. So you can see here the other end. When you look from the top view, I can see the distance with respect to VP, which is in HP. So from this XY line, you measure 60 mm and you will go to get the locus of B in the top view and 50 mm above HP. So he has given the locus of B in the front view, which is 50 mm on this. Now, once you do that, then we need to take the true length now. As we know that this is the true length line in the front view now. You have the locus of B in the front view and you have the locus of B in the top view. We know that the end point of the other end point of the capital B, so that is the true length of the point B will going to lie on this locus, and the true length of the true length of the point B in the top view will going to lie on this locus. So you just with the A dash center, so you just get the B1 dash here because the locus is known. You are given the length also, so you will going to get this A dash B1 dash. Similarly, you get AB2 because that is also the true length, which is going to be the same as both in the front view and as well as in the top view. So this is the top view and this is the front view. So we can see when the line when you look from the top view, I can see the distance A and B2 both are equidistant from the vertical plane, which is 15 mm, and you are going to get this line AB1. Similarly, when you look from the front view, I can see the distance above HP, which is 20 mm above HP here, and this also 20 mm above HP. So now the line is parallel to HP. Since the line is parallel to HP, so we are getting the true length in the horizontal plane, which is A small AB2. Now what we get, so how do I get this point? So we get this point basically because we have the locus of B in the top view and we have the locus of B in the front view. You can observe here that B2, when it is projected down, it will go to cut the locus here. Similarly, with the B1, when it is projected towards the XY VP, so you are going to get this locus. Because of the locus, you have these 2 points, that is B1 and B2. Now, what we want to do, we want to find out the apparent lengths now. So to do that, so since we know this is the true length in the front view, once you have the true length in the front view, obviously that line should be parallel to XY in the top view. So where I am going to get the parallel to XY line? I am going to get the parallel to XY line in the top view because the top view is perpendicular to the horizontal plane. So you can see here small a, when this is projected, you are going to get small a, and when this capital B1 is projected, you are going to get AB1. So this will going to be the length of the front view, top view, because both are in front of AB by same distance. But where is the locus of B in the top view? The locus of B in the top view is here. So that means in the problem he has given it as 60 mm line. So with A as center, taking the radius of AB1 you want to rotate. But in other words, so when you project this, so you can see when you have this capital A and capital B that is in space. As we start rotating, so what happens, you can see the capital A and capital B1 has with A center taking the radius of AB1, you rotate it. Till to what extent you need to rotate? I want to rotate this till to the locus of B in the top view. So when you start rotating in space to reach to this capital point B, so what happens in the top view, the image with small A center, it is being rotated, the top view point. So now it is no longer parallel to VP. Since it is no longer parallel to VP, now it becomes inclined to VP. Since it is inclined to VP, you will not going to get the true length. So naturally, this will going to be the apparent length, which is small AB. So this, when it is projected from here, so you are going to get that the line in space, which is capital A and capital B. Now similarly, when you want to check from the front view now. As we see, look from the front view, you can see that the distance above HP is 20 mm. So this distance is also above HP by 20 mm. Now the line is parallel to HP. Since the line is parallel to HP, you are getting the true length in the horizontal plane. So that is what we have shown with capital A and capital B2. Now, as when we start, when you are projecting from the, when you are looking from the front view, so naturally this point has been projected till here, so this becomes B2 dash and this becomes small a dash. So both are at equidistant from the horizontal plane. Now the line is parallel to HP. So that means when the true length is in HP, obviously that line should be parallel to XY in the front view now. So you can see that it is parallel to HP in the front view. But due to the locus of B which is there, which is above HP by 50 mm, which is already given in the problem. So that this is AB2, which is this line, which will going to be the one which is parallel to HP, which is parallel to XY. But actually what happens, so because due to the presence of the locus of B, which is above HP by 50 mm, that B2 dash will not be above HP by 20 mm, but it should be above HP by 50 mm, such that the length of the line, which is small a dash B2 dash, should not alter. So as we start rotating that in small capital A, capital B2, which is in space, when you are rotating that, what happens to the image of that as you look from the front view? That B2 dash which was here is also being rotated such that it will go into the locus of B in the front view. So that is what we have shown here. This capital B, this is the position where it is joining with B dash. So till where you have the locus of B, till to such extent this capital B can be moved or rotated. So this is how you will be able to analyze this particular problem by using 3D analysis. Now what I want to draw by using the orthographic view, but before that you will go for the stepwise now. When you say the first condition, so he has given A which is above HP and also B which is above HP. A is in front of VP and B is also in front of VP. So as we have the locus in both A and as well as B, so then the true length will going to be on the locus of B in the front view and also the locus of B in the top view. So you know, as we see here, AB1 is the line which is parallel to VP, so you are getting the true length which is in VP. As you look from the top view, both the endpoints which is A and B are 15 mm in front of VP together. So as it is looking this from the top view, this is parallel to XY line in the top view. So obviously this line is in true length, so that means you have this line is in true length now. Now due to this locus of B in the top view which is 60 mm which is here, so you are getting this. So what happens as you rotate this and also when you look from the front view, you can see that when you look from the front view, you can see that AB2 is the one which has been parallel to XY line. But as we look from the top view, both AB1 which is in front of AB by 15 mm each, so naturally this distance which is going to be the parallel to XY, the top view. So with A as center taking the radius of AB1 as being rotated, so what happens to the image on the XY line, or it is from the HP, so naturally that image is also being get rotated. Till what extent it will going to be being rotated? Till that B will going to cut the locus of B in the top view. So once you get this position, you join. So this is the actual line which is going to be in space, and all other lines are the images. Now that is what we have shown here. First we have taken the XY line, so we have taken the true length in the front view and as well as true length in the top view. How do I be able to get it? Because you know the locus of A and you know the distance with respect to distance of the point A with respect to both HP and VP. Similarly, the distance of the point B with respect to HP and VP is known. So once you draw this, then you have the true length of the line which has been given as 70. So you cut it here and also you got the true length here. As we know that it is the true length in the top view means it should be parallel to XY line in the front. True length in the front view means it is parallel to XY line in the top view. How do I be able to get the top view true line? I will be able to get the parallel to XY line. You can see here as you look from the top view, A and B1 which are at equidistance from the vertical plane. So as you look, the image will going to form from HP. So this small AB1 is the line which is parallel to XY because A and B are at equidistance. So that is what we have shown. A and B or A and B1 are at equidistance. But as the locus of B is present which is 60 mm in front of VP, so with A center taking the radius of EB1, B get rotated till it cuts the locus of B in the top view. So that is what we have done. As we are rotating it is in space such that the B1 will going to come and touches the locus of B in the top view. So as we are projecting, both the point will going to meet it will going to meet at this point. You got capital B, so this is the actual line which is in 3D space. Now that is what we have done here. As we are rotating with AB1, it cuts the locus of B, you are going to get small b and you get the small a. So similarly, you take it into the front view now. So you have this true length, so you have the end projectors, there is the locus of B in the top view and as well as in the front view, and you have the front view locus in top view and front view now. So we have the true length in this front view and the true length in the top view. Now we are going to consider the true length in the top view now because we are already found out what is the top view. Now we have to find out the front view. So to do that, take the true length top view. So when it is in true length, obviously that line should be parallel to XY in the front view. So where do I be able to get that? You can see that 20 mm is above HP, which is A dash, and B2 dash is also above HP by 20 mm. So that is what we have seen here. Both are at equidistance from the XY line or the horizontal plane. So because due to the presence of the locus of B in the front view, so with A dash as center, taking the radius of A dash, B2 dash is being rotated such that it is going to get the locus of B in the front view. So that is how you are going to get A dash, B dash, and you show the directions. So that is what we have done. Now how to analyze that by using, how to draw this by using the sketchbook. So first we are going to draw the XY line and mark VP and HP, which is as shown. As we know that NDA is 15 mm in front of VP and 20 mm above HP. So since it is VP, it will be obviously on HP. So from XY line you measure 15 mm and draw a horizontal line. So this is how we are going to start drawing in sketchbook now. Similarly, 20 mm above HP, so obviously it should be on VP. So from XY line you measure 20 mm and draw the horizontal line. So both these two horizontal lines are parallel to the XY line in the both front view and as well as the top view. So consider any point and draw a vertical projector and you mark this as A dash and you this as small a and this as capital A and this as capital A. And show the dimensions of 20 and 50. Similarly, as the other end is 60 mm in front of VP and 50 mm above HP. So from XY line you measure 50 mm and draw a horizontal dashed out line which is going to be the locus of B. Just write locus of B. Similarly, from the XY line you measure the distance of 60 below the XY line and you draw a horizontal dashed dot line which is parallel to XY line in the top view, and you mark this as locus of B. Now as he has given the true length is given which is 70 mm. You know that the true length is both in the front view and as well as in the top view we are going to have the same distance. So by using the compass you measure the radius of 70 with A dash as center, cut an arc on the locus of B in the front view, and with this center A, again you take the same radius and cut an arc on the locus of B in the top view. Now once you got this, so you are going to get this is you write it as A dash and capital A, and this as small letter A and capital letter A. Then you mark this point as B1 dash and you mark this as B which is in bracket, which is B, and this is also B2, and you identify these two as locus of B. So join A dash B1 dash with little bit thicker than the XY line and A B2 with little bit thicker than the XY line. Now we need to find out what is the front view and top view now. So you consider the true length in the front view, obviously that line should be parallel to XY in the top view. So in the top view, A is in front of VP by 15 mm and B1 should also be in front of VP by 15 mm. That is what it is quite evident here. Both capital A, B1 when you look from the top view are at equidistance. So now draw a vertical projector from B1 dash to the locus of B, that is AB1, to this line, and mark this point as B1. By using the compass with A as center, taking the radius of AB1, you draw an arc such that it will go to cut the locus of B in the top view here, and you mark this point as B and join A to B with a dot line. Similarly, when you are considering the true length in the top view, obviously that line should be parallel to XY in the front view. So from B2 you draw a vertical projector such that it will going to come and meets the locus of A in the front view, and you mark this point as B2 dash. But the locus of B in the front view is not 20 mm above HP, but it is 50 mm above HP, such that the length of the line should not alter. So that is possible only when you are rotating this. With A dash as center, by using the compass, you measure the radius of A dash B2 dash and you draw an arc such that it will go to cut the locus of B in the front view. And you mark this point as small b dash and join A dash B dash with a dot line. And you mark the angles and the dimensions. So you mark this as theta and alpha and phi and beta. Theta and phi are the two inclinations with respect to HP and VP, and alpha and beta are the apparent length, apparent inclination with respect to both HP and as well as VP. So when by using the protractor you measure the angle of theta, which will be 25 degrees, and alpha it will be 34 degrees. Similarly, with B A center, taking the radius with A center, by using the protractor you measure the angle with respect to this horizontal line, which is AB1, will be phi, which will be equal to 40 degrees, and with the same center A you measure the angle of the apparent length, which is top view, which is beta, which will be 45 degrees. So, and show the answers here. So this is how you will be able to analyze in 3D and as well as in the orthographic view of the projections of lines. Thank you.